Hey, Wilma, I'm home.
We're back with more algebra for you. Now today, I got to give you a little warning. We're going to cover working with your old buddy, fractions.
Oh, I'm dying.
Don't worry. Don't go crazy on me. Don't go away and get dinner, okay? Fractions are going to be the same. We're going to have the same rules as you learned in pre-algebra. Actually, it's just going to be a review. The only new thing is probably going to be factoring. We're going to throw that in there, but you already know that too, okay? Anyway, that's what we have to cover today. Don't forget, if I speak too fast, that you can always go to the homepage at www.montgomerycollege.edu/algebra. Now, I think it would behoove us to review just a teeny bit of factoring, because that's going to be integral to all we do here, okay? So we didn't just learn, here's just another use for factoring, okay? Remember, and I'm not going to actually do any problems here, I'm just going to review the basic checklist I'd like you to follow through every time you try to factor something, okay? And that is, we're always going to first look for a greatest common factor of the whole expression to see if we can take it out to make the problem easier. Then, we're going to look for the difference of two squares, and that'll stick out like a sore thumb because it'll be two things with a minus in between them. And then, if one of those two isn't the case, then we're going to look for something of the form ax squared plus bx plus c. Okay, remember that? I hope you do. You're going to need to know it. Okay, let's try and look at working with your old enemies, fractions. First thing we want to do with fractions is simplify them. Okay? Now, what's this idea of simplifying fractions? What does that even mean? Okay? Well, the idea of simplifying fractions is the same as canceling. You've heard that before. It's also the same as dividing by 1. Well, that seems weird. Dividing by 1, how does that one fit in there? Canceling, simplifying fractions, how does dividing by 1 fit in there? Well, let's take a look. Consider, what is 2 over 2? You know what it is. It's 1. Well, okay. What is that? Then what is 13 over 13? Yes, it is also 1. What is x to the 5th over x to the 5th? Yes, it is 1. Well, what is, to the point where we understand this, to the point where you're sick of it, what is hunga chapabwa over hunga chapabwa? Yes, anything over itself is 1. Okay? Your old buddy 1. And remember, what can we do with 1? We can throw him around like cheap meat. We can use it as the identity element of multiplication and division. It doesn't work for addition and subtraction, but you can multiply and divide by 1 like you've never seen. Anything times 1 is itself. Anything divided by 1 is itself. Okay? In any of 1's forms. Okay? Now wait a minute. A minus 1 is itself? No. It only works for multiplication and division. Okay? So we're going to be able to throw 1 around like cheap meat when we're working with multiplication and division. Okay? So this is something we're going to use when we go to simplify fractions. Well, let's take a look at some canceling. 8 over 12, you've done this one kind of like this before. Okay? Where does dividing or multiplying by 1 have anything to do here? Well, in this case, let's factor 8 and 12. 8 is 2 times 2 times 2, and 12 is 2 times 2 times 3. I just broke it up as far as it would go. And I'm going to cancel every occurrence that's in the top that's also in the bottom. And what am I going to get but an answer of 2/3? You've done that before. Why can I do that? Well, basically what I did is I divided by 1. And remember, you're allowed to divide by 1 any time. I divided by 1 in the form 4 over 4. Notice the 2 times 2 and the 2 times 2. See? There's your old buddy 1. Okay? And 8 divided by 4 in the top would be 2. 12 divided by 4 in the bottom. As long as you do the same thing to the top and the bottom, we've got division by 1. Now, don't get nervous if we do the same thing with variables. Okay? Same thing, as long as we divide the top and bottom by the same thing, we're dividing by 1 in one of its crazy forms, perhaps. Okay, let's take a look. In this case, x to the second, y to the seventh, couldn't it be written factored? That's x to the second, 2 x's, and y to the seventh, 7 y's, right? And x to the fifth, 5 x's, and y to the third, 3 y's. Okay, now, since we factored, good old buddy factoring, we just cancel. Let's see, who's on the top and on the bottom? Well, let's cancel there, cancel there. Anybody else the same? How about, okay, I'm left with, as far as x's, on the bottom, because that's where most of them were, I'm left with x to the third. Any y's can cancel? Of course. I'm taking out, let's see, 3 of them. Doesn't matter which ones, as long as they're on the top and the bottom. And I'm left with, looks like, what, 1, 2, 3, 4 of them on the top. And there's your answer. Now, why could I do that again? Because I divided by 1 in the form, in this case, x to the second over x to the second. And then in the other one, when I canceled, I divided by 1 in the form y to the third over y to the third. So I'm not breaking any rules. I'm not making any rules. I'm using the identity element of 1. Let's do another one. Ouch! Wait a minute. Can you cancel that? No. No. Why can't I cancel that? There's no reason why you can subtract 2x squared from the top and 2x squared from the bottom. Remember, I told you this only works for multiplication and division. If you were to get rid of that 2x squared, you'd be subtracting. That's why you'll always hear the term, don't cancel things that are added, because you're not using the identity element of 1 multiplication and division rule. And you can't make up your own rules, okay? So what are we going to do here? Well, we're not going to think about canceling things that are added. Let's see. I'm thinking this is a job for
Factor boy.
Factor boy. Let's factor and see what we can do here. If I factor the top, of course I go through my steps. First thing is to take out a common term, which I can do in this case. I took out a 2x, and that's all that's left. The whole top is factored. In the bottom, let's see, I go through my steps, and it ends up being 2x plus 1 times x plus 3. Now I factored, and I'm looking in the top and looking in the bottom, and I'm seeing something that's the same. That is multiplied. So I can cancel it, because it is multiplied. Note that factoring creates multiplication. That's why we did it. Now you're allowed. It's perfectly legal to divide by 1, but not legal to subtract by 1. Okay? So there's your 1. X plus 3 over x plus 3. Remember, anything over itself is 1, and you can divide by that. So your answer will be what's left, 2x over 2x plus 1. You're thinking, can I cancel those 2x plus 1s? Uh-oh, here comes your boy again. Don't even think about it, because that would be subtraction. Okay, get the idea of canceling? Bam. Okay, now there's a little bit more to this. Your old buddy, not your old buddy, the -1 over -1 trick. Let's take a look at it. Sometimes it gets weird. What is -1 over -1? What did I tell you? Anything over itself is 1, even the negative ones. Okay? No, it's perfectly legal to divide by that number, even though it's negative, as long as it's the same thing over the same thing. Okay? So how are we going to use this? Well, let's see. If we had to cancel this, let me factor, because I can't cancel things that are added. There's my buddy. Let's see. In the top, I'm going to factor this, and it's going to be x minus 2, x minus 2. Okay, now the bottom is the difference of two squares. So that's actually going to factor to 2 minus x, 2 plus x. Is there anything that's the same in the top and the bottom? Well, let's see. These two smell alike, x minus 2 and 2 minus x, but they're not the same. They have to be the same. So here comes my buddy again. It's got to be the same thing over the same thing, or it's not 1. So what are we going to do here? Can we do anything? Well, there's a trick. We're going to multiply by 1 in the form minus 1 over minus 1. Now the reason we're going to do this is because we have kind of a form of x minus 2 and 2 minus x. It's the flip of the other one. Now as long as I multiply top and bottom by negative 1, I'm going to be okay. It doesn't matter when I do it, as long as I do it. So I'm going to do one, and timing is key. I'm going to do one a little earlier than the other, but I'm going to do it. Let's take a look. I'm going to do the bottom one earlier and the top one later. So if I multiply the bottom one earlier, I'm going to multiply, let's see, minus 1 times 2 and minus 1 times x. Minus 1 times 2 and minus 1 times x is going to give me minus 2 plus x. Couldn't I write that another way? How about x minus 2? You would kiss x minus 2. You would marry x minus 2, wouldn't you? Because now it's your buddy, because it's going to cancel with what's in the top. And we're going to multiply the other top later. Okay, so we'll just leave the minus 1 in the top. Okay? There's that minus 1 still in the top. Why did I do that? I don't want to multiply yet, because now I do see two things that are the same in the top and the bottom, and they are multiplied. And I'll cancel them, x minus 2 and x minus 2. And that leaves me with my minus 1, which I can multiply or not multiply. I choose to do it here. I'll get that, and I'll get minus x plus 2, and in the bottom, known downtown as 2 minus x, and in the bottom, 2 plus x. Okay? And that's all you can do, can you? That's all you can do in this problem. That was pretty good, though. Okay? That's tough, that minus 1 over minus 1 trick. We're going to revisit that later. Okay? So don't worry, we'll review it. Okay. Now, a very similar thing happens when you multiply and divide fractions. Let's take a look. When we multiply and divide fractions without variables, just regular old numbers, we use the rule a over b times c over d equaled, just multiply the tops, a times c, and multiply the bottoms, b times d. Okay? For example, if we wanted to multiply 1/3 times 2/7, what did we do? Well, we multiplied the tops, 1 times 2, and we multiplied the bottoms, 3 times 7. Very simple, isn't it? And we got 2/21, and that is the answer. Don't make crazy out of it. Okay? Well, should anything change? Well, sometimes you have to cancel. Okay? Let's take a look at another example. 1/15 times 5/11. Now, we could do our multiplication, but I always suggest to people, if there is canceling involved, let's do that first so we don't get high numbers. Let's see. 1 times 5 and 15 times 11. Ew. Tell you what, let's cancel, as I said, before multiplying, so I won't have to do that high multiplication of 15 times 11. At least I'll be working with smaller numbers. Okay, so what can I do first? Doesn't matter which you do when, but it's more strategic to cancel first. Okay, so let's see. I'm going to cancel the 15 with the 5. Basically, who can I divide by here? Dividing both of them by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. Now, I don't see anything else I can cancel, so now, and only now, I can multiply. The tops, 1 times 1, and get 1. And the bottom, a little bit easier multiplication, 3 times 11 and get 33. You're saying probably, we already knew this. Okay, we did that last semester, or I did that way back when. Good, because the rules aren't going to be any different for algebraic expressions. Okay, we're going to multiply the tops, multiply the bottoms, and if there is canceling, we're going to do it first. Let's take a look at an example. 3x times 7y and y to the second times 4x. But before I do the multiplication, do you see anything that I could cancel? Well, let's do it. The y to the second and the y, leaving me with what? A y in the bottom. Okay, remember that's a y to the first in the top. The x's are out of here, and that leaves you with, a little tricky you could think, it leaves you with x to the nth. But remember, anything to the 0 power is 1, so we could just cancel them. Okay, is there anything else I can cancel? I don't see, so let's just do our multiplication. 3 times 7 is 21, and 4 times y is 4y. Now you can write y 4, but we usually write 4y. And there's your answer. Oh, they get harder than that. Holy, go to war, Miss Agnes. Let's look at this one. This is like basically 4 factoring problems, really. Okay? Relax, Francis. It's not that bad. Let's factor. Uh-oh. Wait a minute. Would you cancel those? Would you cancel those? Don't even think about it. Why wouldn't you cancel those anyway? You wouldn't do it because if you were canceling them, you'd be canceling things that are added. Remember, there's no rule that says that you can cancel things that are added. Okay, it's only multiplication and division. We're dividing by 1. So, this is a job for guess who?
Factor boy.
He's our buddy. Let's factor. Let's do the top. You know what I like to do? I'm not going to work top to bottom, etc. I work with the easiest ones first, okay, whichever looks easiest to me. Because a lot of times, the easiest one will give me a clue. I know it's not fair to do this, but will give me a clue to what the hardest one is. Okay, so looking at that bottom left one, I knew right away what that one was. So I factored that, okay? X plus 1 and x plus 3, okay? And then the far bottom right one was a difference of 2 squares, and I factored that, x plus 3, x minus 3. Okay? Well, let's see. Who's the next easiest one? I don't know. It doesn't matter. Okay? But now the reason I did that, by the way, in this one, x minus 3, x plus 2, I could have used 1 and 6, but I smelled 2 and 3, didn't you? Now, that's really not a fair thing to do, but since you're always checking anyway, I always do the easiest ones, and as I said, they're going to give you a clue to the harder ones. Okay, we have one left, and that's going to, I smell not 1 and 9, but in this case 3 and 3. And if you check it, that is what it is, x plus 3 and x plus 3. Well, now comes the fun part. Okay, it's okay to factor now, because everything's multiplied. Okay, we're not canceling things that are added. Let's see. I'm going to have the x plus x minus 3's gone. Anybody else the same? There's some x plus 3's, bam them. Anybody else? Oh, there's another x plus 3's gone. And that leaves me with, I don't see anything else to cancel, x plus 2 over x plus 1. It's easy, thanks to Factor Boy. Let's look at another one. The rules for division are the same basic deal for multiplication with one little twist. Okay? And you remember this from pre-algebra. If you want to go a times b, a over b divided by c over d, what's different? That's going to be the same as, well, actually you don't divide. You're going to multiply. It's the same as doing a over b times d over c. So basically we just reciprocate the second fraction and multiply. And since you already know how to multiply, you're goony-goo-goo. That's all you have to do. You reciprocate the second fraction and multiply. Okay? Of course, you have to know how to reciprocate. Let's take a look at a regular problem. 7/8 divided by a half. What would that tell me to do? Well, there would be 7/8 times the reciprocal of a half, which is 2 over 1. Okay? Now, I could just multiply, but remember, what do we do before multiplying? We try to cancel before we multiply. We could cancel later, but then we'll have high numbers, and that's a source of error. So let's cancel the 8 with the 2. What are they? Both divisible by 2. 2 goes into 8 4 times, and 2 goes into itself 1 time. I like to write the numbers there. And now I've done all my canceling. I can just multiply. 7 times 1 is 7, and 4 times 1 is 4. And bam-a-rini, there's your answer, 7/4. You could write it as a mixed numeral as well. Okay? Well, holy go to war. Look at this one. Let's do division with polynomials. Not so bad. It's going to be changed into a multiplication problem. I'm going to take the first fraction, in this case the green one, they're not always green, and multiply it times the reciprocal of the second fraction. So let's just flip that second one, put 4m squared minus 9 in the bottom, and put the bottom in the top. Okay, and do multiplication. It's not so bad, is it? But we're going to cancel once again before dividing or before multiplying. Okay? Can I cancel these? Can I cancel these? Don't even think about it, Buford. Those are added. We can only cancel things that are multiplied. I'll tell you every time. Okay? Can't cancel things that are added, only multiplied. Okay? What creates multiplication? What creates multiplication? Your old buddy.
Factor boy.
Hi, Mom. That's what creates multiplication. That's another reason why we learn to factor. Let's factor like you've never seen. Let's see. What's the easiest one of the 4? Let's take a look. I don't know about that one. Oh, wait a minute. No, I don't think that's the easiest. That's pretty easy. That's a difference of 2 squares. I think I'll go with that one. Okay? Remember the difference of 2 squares? 2m plus 3, 2m minus 3. Okay? Okay, anything else? Well, that one, the bottom left one looks easy, since there was nothing in front of the m squared. I'll factor that. That's m plus 5 and m minus 4. And I'm thinking the top right one is the next easiest one. Okay? Notice that I saved the hardest one till last. That's going to give me some clues from the other ones. Okay? Now, it may not work out that way, but I'll tell you, usually with these math books it does. Okay? Let's see. I smell 2m plus 3. And if I factor 2m and m, that's why I use 2m and m. And what are we going to use for that 12? Well, I smell 3 and 4, don't you? That's why I smell it. Look at those two. In fact, I smell specifically that the 3 will go with the 2. Okay? I may be wrong, but it's worth, since you're trying a hit or miss, it's worth trying it first, if you would. And of course, you'll check it. Okay? And I'm looking at that 4, and I smell that that's the answer. And I try it, and it works. Bam! So use that as a clue. Do the easiest ones first. Okay. Now it's okay to factor. To cancel. Okay, the m minus 4s are gone. This is kind of the fun part. Okay. M plus 5s, they're out of here. Anybody else? Oh, look at this. This is going away like you've never seen. And the only thing that's left is m minus 1 over 2m minus 3. It's not so bad, is it? Here's a tricky one. Okay. This is division now, so we're going to reciprocate and multiply. Let's see. I don't reciprocate the first one, only the second one. So that'll be x squared minus 4 over 4y times the reciprocal of the second fraction. So let's put the 2 minus x in the bottom and the 6xy in the top. Okay? Now, I'd like to cancel,
Factor boy.
but I don't even have to introduce. You know that we have to factor first. Okay, who can we factor? I only see one. I'm going to factor that top, and it smells like the difference of 2 squares. Okay, I think everybody's set, everybody's multiplied, everybody's in a multiplication state. Okay, and now I'm ready to cancel, except that I'm looking at these two, and they're not exactly the same. Remember the trick that we used when we had something that was of the form oogie minus juggy and juggy minus oogie? In this case, I get x minus 2 and 2 minus x. We used the minus 1 over minus 1 trick. Well, let's try it here. I told you this one was tricky. Okay? Remember the minus 1 over minus 1 trick says do it to both top and bottom. That's good. That's the identity element of 1. Okay? But timing is key. We'll do one earlier and one later. Okay? Let's do the bottom earlier. And you know what? It really doesn't matter. You can do the top earlier and the bottom later. Okay? So you don't have to memorize that. As long as you do one, then cancel, then do the other. Okay? But in our case, we're going to do the bottom earlier. Okay? So if I do the, and then I'll do the top later. Multiplying -1 times 2 and -1 times x, I'm going to get actually -2 plus x, but that could be written x minus 2. Okay? You love x minus 2. Okay? Because now I'll write the rest of it. Notice that the bottom -1 is gone because he got combined already. The top -1 is still there because he hasn't been multiplied yet. Okay? Well, now I'm in Fat City because I can cancel like you've never seen. Those x minus 2's are exactly alike, and I can use the identity element to cancel them, dividing top and bottom by the same thing. Anybody else? Oh, there's some y's. They're out of here. And the 4 and the 6 are both divisible by 2. 4 divided by 6 is 2. 4 divided by 2 is 2. And 6 divided by 2 is 3. So let me look at what's left over here. Let's see. I've got the -1 times the 3. That gives me a -3. And then the x plus 2. Now, I haven't multiplied that out, and I may choose to do that later. And then anybody in the bottom? There's a 2. And that's a viable answer. You could write that as the answer. Or you could multiply it out. Okay? Let's do one more to look at the whole schmoo. Okay? To bury this. Holy go to war. Holy go to war. Well, I've got a multiplication and I've got a division. The division, I'm going to reciprocate. Okay, so let's rewrite this bad Johnson. Okay, reciprocating just the blue one. And now it's time. Don't. If I ever see you canceling something that's added, you better look over your back. Okay, what do we know we have to do here? We cannot cancel added things. We need to factor. Okay, that one doesn't factor, so we'll just write it. Oh, no, I took a 2 out. That's right. Okay, who else is the next easiest one? How about this guy? I can take out a -20, which I'll do. Okay, anybody else? Who's going to factor next? Then I broke it up. Let's factor this guy. I smell that I can take out a 5 and then factor further the x squared minus 2x minus 3, and I'm left with that. Remember, you want to factor as far as it'll go. Now notice I'm going through the steps as I'm factoring. Okay? Okay, who do we want to factor next? Okay, this guy. Ooh, that's a tough one. Okay? If I factor it, 3x and x, I'll make, it's either 7 and 1 or 1 and 7. There, that's the right guess. Okay? No, it's not. I got to check your factoring. That gives me a 7 and a 3, gives me the 10, and I'm looking good there as far as the rainbow. Okay, now we're getting to the tougher ones, but I'm going to use the other answers as clues to this. Okay? I smell 2x and x, and for 18, what are you going to use here? 3 and 6, that gives me a 12 and a 3. That's no good. Let's try, that gives me a 6 and a 6. That's no good. That gives me a 2 and an 18. Holy go to war. How about 9 and 4? There's your buddy. That gives you the 13 rainbow. Okay? This is tough. This is the big leagues. Okay, let's take a look at this one. 2x. You see why you needed the clues? I know 2x and x. Now, I kind of smell 9 because of that 27, and looking above, I kind of smell 9. So that's the one I'm going to try first. Let's see. 9 and minus 3. That gives me a -6 and a +9, and you love that. Good thing I used the clue. I don't got to try 22 possibilities. Okay, so use your clues. Okay, now here comes the fun part. Cancel, 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 cancel. Bam! I love this. Ooh, I'm loving this. Oh my gosh! What's left? Anything? Oh no, the 2 goes. I am canceling like you've never seen. Okay. Well, when I cancel the 2's, you have to, put something there. That's going to be important because there has to be a top. Okay, and I don't see anything left in the top. So when I cancel everything, there's a left. You'll be left with a 1. Note that. Okay, that could happen. Okay. Bam! Like sometimes you can cancel the things that are canceled. Dividing both by 5, there again, I'm left with a 1 here and a -2 here. Anything else? I believe that's it. So let's see. In the top, I'm going to have 1 times 1, and that'll be 1. And in the bottom, 3x plus 7 and -2, and that's your viable answer. Okay, note that you had to have something in the top. You don't have to have a bottom, but you have to have a top. And you could multiply it out or not multiply it out, however you wish. Okay? Either one is a viable answer. Okay? Remember, don't even think about canceling things that are added. Okay? That's probably the most important thing in this section. The rest of it you probably already knew. Okay? Okay, now we're going to start one more thing where we're going to manipulate fractions, that is adding and subtracting them. But before we talk about that, we need to talk about least common multiples, known downtown as least common denominators when we talk about fractions. Okay? Remember when we talked about multiples and we talked about factors? Now up to this point we've been really worried about factors. What's the difference? Okay? Well, the factors of 12 are the things that go into 12. Remember, 2 goes into 12, 3 goes into 12, 4 goes into 12. So those are the factors of 12. The multiples of the 12 are the things that 12 goes into. So they're going to basically be bigger. 12 times 2 is 24, times 3 is 36. These are the multiples of 12. Okay, so we're kind of working backwards when we're talking about multiples. Let's look at 50. The factors of 50. 2 goes into 50. 5 goes into 50. 10 goes into 50. Okay, all these things that go into the number are called its factors. Whereas the things that like 50, go into are multiples of that number. Of course, there's way more than what I'm showing you. Okay, but that's just to give you the idea what the difference between factors and multiples mean. Okay? Now, we want to talk about common multiples of 2 numbers. Okay, well that's simple. It's just going to be the multiple that's the multiple of both numbers. Let's take a look at this. Well, let's see. The multiples of 30, some of them are 60, 90, 120. The multiples of 45 are 45, 90, and 135. So when we talk about common multiples, we're looking at something that's a multiple of both. This is just basic English. Okay? Well, common multiples, when we deal with fractions, are called common denominators. Okay? Well, that's what we're going to be using. So we're going to do the same idea. You're going to be asked in the future to create or construct, I like to use the term, a least common multiple or a least common denominator of several numbers. Let me give you a way that will always work. Okay? Let me give you a couple numbers. First of all, you're going to break up those numbers just like we did into all their factors. Okay? And then you're going to construct not the intersection of those sets, but the union of those sets. You're going to create a term that contains every factor from both of the sets. Now, I'll need to show you what I mean by that. Okay? Let's find the least common denominator of 20 and 15. First thing we're going to do is break them up as far as they'll go. We did this with factors, remember? Okay, let's start with 4 and 5. Now, 4 can be broken up further, so we'll break him into 2 and 2. Okay, I don't see breaking this up any further. So that's if you would, the prime factorization of 20. 2 times 2 times 5. 15 I'll break up into 3 and 5. Okay, and they can't be broken up anymore. Well, now I'm not going to take the intersection of these two sets like I did before. To find the least common denominator, I'm going to take the union. In other words, I've got to create something that has covered everything in both sets. Let's go one thing at a time. The 2 I need, so I'll throw him down. This 2 I need, because I need 2 2's, okay, so I have to put in another one. If I have 2, I had 3, I'd have to put in 3, okay? Okay, the 5 I need. I don't have a 5 down here yet, okay? Now let's see, that takes care of everybody there. The 3, don't have a 3 down there, okay? Now this 5, I already have. You say, well, you have 2. No, I don't have 2 in either set, so I don't have to add 1 in this case. Okay, so I really covered everybody. So I really have the answer here. If I multiply them, 2 times 2 times 5 times 3, and get 60, believe it or not, that is the lowest number that 20 and 15 both go into, or the least common denominator of 20 and 15. Okay, let's take a look at another example. What's maybe something perhaps with variables? Ooch, not so bad. Well, let's break it up as far as it'll go, okay, into its prime factorization. X squared y would be two x's and a y, okay? That's what exponentiation means, right? And we're going to break this into its y to the third and x. Of course, we'll have 3 y's and the x. Okay, now we're going to construct a number or an expression that has covered everybody in both of those green sets. Okay, let's see. I need an x. I need another x. Okay, that covers those two. And I need that y. So I'm all set for the first number, x squared y. Now the other one, I need a y. Well, he's covered. I already got him. But I don't have this guy and this guy. Okay? And now I have the 3 y's from that set. Okay? This x is already covered as well. Okay? So it looks like the least common denominator in this case, multiplying, is x squared y to the third. And that that is the deal. Okay? Eat my tongue a little bit here. Now I'm checking. Is x squared y in there? Yes, it is. Okay? I'm checking, is y third x in there? Yes, it is. Son of a gun, it is. And that's the smallest number that they're both in. You always want things to be small because they're easier to deal with. Okay? Okay. Let's do one more so you get the idea. The least common denominator, y squared plus 5x plus 6 and 5x squared plus 15x. How in dog lips would I do this? Well, just like before, we factor as far as it'll go. That factors into, remember your old buddy factoring? Yes, it does factor that. And this one, I can take out a common term, factors to that. And that's as far as they'll go. I'm playing the same game, aren't I? Okay, now I just got to cover everybody. Let's see, I need an x plus 3 and an x plus 2. Okay, and that covers the first number. And I need a 5x. Do I need another x plus 3? No, I don't in this case because I already have one, so I'm covered there. And that would be, if we needed one, the least common denominator of the two. I see that everything in x squared plus 5x plus 6 is there. And I'm looking to see that everything in 5x squared plus 15x is there. And son of a gun, there it is. Okay? So it's the same principle, isn't it? Okay, now why would I need to do this? Well, if I want to add rational expressions or fractions, I'm going to need to find them. Well, first of all, let's do the easy ones. To add fractions with like denominators, for instance, 4/3 plus 1/3, you did that way long ago. That's just 5/3. So all you did was add the numerators and keep the same denominator because they're already the same. Okay? Let's look at another one. 7 over y, ooh, letters. 7 over y plus 2 over y, same rule. all you have to do is add the numerators and keep the same denominator. That's when you have the same denominator. Uh-oh, what about this baby? Once again, when the fractions have like denominators, all you have to do, if you can, is add the numerators. 3x plus 2 is just 3x plus 2. Okay, and put it over the same denominator. So, as I said, when you have fractions with the same denominators, just add the numerators. That's simple. Okay? Now I want you to think about something. Remember, what is 2 over 2? What is 13 over 13?
Great horny toadies!
Yes, it is 1. You've seen this before. X to the 5th over x to the 5th. 1 again. Hungapachabwa over Hungapachabwa?
Any of this getting through to you, son?
Yes, it's 1. Okay, how is this going to be involved here? Once again, remember, the only thing we're allowed to do with 1 is multiply and divide, and we're going to be multiplying in this case. Let's take a look at what we're going to do with that. The identity element of 1 says that I can multiply anything by 1 and get itself. I can divide as well, okay? What I can't do is subtract or add.
What a maroon. What an ignoramus.
I'm telling you, don't even think about doing that, okay?
Yo.
Only multiply or divide. Let's take a look. We're going to add some fractions. This is a tough concept. A lot of people have trouble with it, with unlike denominators. We're going to add 4/3 and 1/2. I like to do it vertically like this. What does that equal? Well, we're going to get a least common denominator. A least common denominator of 3 and 2. In this case is 6. Okay, now I'm going to create equivalent fractions. We did this way long ago. I'm going to say, what did I multiply 3 by to get 6? I multiplied it by 2. So 4 is saying, you've got to multiply me by 2 as well to do the one identity element rule, and I'll get 8. And everything is hunky-dinky, as long as whatever you do to the bottom, you do to the top. Okay? What did I do to 2 to get to 6? I multiplied it by 3, so what is 1 saying? Hey, what about me? Okay, we'll give you your 3 as well, because that will be using the rule of 1 and get a 3. Well, now I've got 2 fractions that have the same bottom, and all I do is add numerators. 8 plus 3 is 11, so 11/6. And that's the idea. Let's try it with variables. 15 over 7a and 8 over 6a. We need a least common denominator here. See how it's nice that I write them vertically? That's going to be, in this case, 42a, the smallest thing that both 7a and 6a go into. And I ask myself, what did I multiply 7a by to get 42a? Well, in this case, the answer is 6. So 15 saying, hey, what about me, Buford? Okay, there you get your 6 as well. And we get 90 in that case. What did I multiply 6a by to get 42a? 7. Okay, 8 saying, I need my 7. And we'll give it to him. Okay, now I have two fractions with the same denominator. All I need to do is add the tops. And what do I get? I promise you, 146 over 42a. Now, you might have to cancel, okay, as you would any answer. Okay, and if I cancel here, I'm going to get 73 over 21a. But that's nothing new, okay? So always look to cancel, okay? Let's take a look at a little bit more difficult LCD, okay? We need the LCD of 3x squared and 5y. Well, let's see. It's not so bad. I'll cover everything. I'm going to need a 15. I'm going to need an x squared and a y. Okay? Now I got to say to myself, just like I did before, what did I multiply 3x squared by to get 15x squared y? And in this case, of course, you could divide. The answer is 5y. So I got to give that to a 5y to be legal. Okay? And that is as legal as Schmiegel can be, because you use the rule of 1. What did you multiply 5y to get 15x squared y? Well, 3x squared. So x1's his as well. And I'll multiply those out. Now in this case, all I have to do is add the numerators, but I can't. They're unlike terms. So what will I do? I'll just write them. That's all you can do. Sometimes that's all you can do. Okay? Let's take a look at another. I need a least common denominator. Before I get a least common denominator, I'm going to have to factor. Okay, let's take a look at these babies' factors. Getting a least common denominator of the two denominators. I need to cover everything. Wow, look at that least common. I need an a plus 9, I need an a minus 9, I need a 2, and I didn't need another a plus 9. Okay, so there's your least common denominator. And then I say to myself, what did I multiply this by to get the least common denominator? In this case, the only new guy is 2. So I'll multiply the 27 by 2 and get 54. What did we multiply here? Well, the new guy is a minus 9. So I've got to multiply that 3 by a minus 9, and I get 3a minus 27. Adding the numerators of these now fractions that have the same denominators, it's not so bad. Adding like terms, 54 and minus 27, I'm going to get 3a plus 27. Is there any more that I could possibly do? Remember I warned you, you always got to be looking for canceling. Well, the bottom's factored. Let's factor the top. Good thing I did, because now I can cancel. And I'm thinking that's the answer, 3 over 2 quantity a minus 9. That's a tough one. Now this one looks easy, but, if I factor, x plus 5, x minus 5, it's going to be a tough least common denominator. Remember that these are not the same thing, but we could use your buddy, the minus 1 over minus 1 trick, or something. Let's take a look at what we're going to do here. I'm going to multiply. Remember, you can throw it anywhere you want, minus 1 and minus 1. So I'm going to say that this new improved fraction is not 3 over 5 minus x, but rather minus 3 over x minus 5. Okay? You can, whenever you have the flip of something, as long as you do it to the top and bottom, you're going to be okay. Okay, so now I got an x minus 5. It makes for an easier LCD. Well, let's see. Least common denominator here is going to be x plus 5, x minus 5. Sometimes, I didn't, as I look in the top, I didn't have to multiply by anything, so I just leave the top the same, and in this case put an x, or you say I multiplied by 1. And in the bottom, I had to multiply by an x plus 5, so I'll do that in the top, getting minus 3x minus 15. Okay, let's add like terms, and we got ourselves an answer. Is it factorable? You got to look. It isn't in this case, but you always got to look. So that's your answer. Now that's the hardest one you'll get, so don't let that scare you. Okay?
I'd better get out of here while the getting's good.
Okay, that's enough. People say, I've learned quite enough, thank you very much. Okay? Don't forget that you can always go to the home page. I know I talk fast, and you can look at this nice and slow at www.montgomerycollege.edu/algebra. And remember, it doesn't help to listen to me babble if you don't do your
Hasta la vista, baby.
homework. Have a good one.